This video will be talking about the Z-effective effect on the atom and properties that it has. So the first property that we can talk about with atoms is its radius, how large it is. And because it's a sphere, we can talk about it in terms of radius. So as the Z-effective increases, the atomic radius decreases. This makes sense because opposite charges attract, valence electrons are negatively charged, and the nucleus is positively charged. So the more strongly the nucleus pulls on its outer electrons, the more closely all of the electrons are going to be drawn to the nucleus. Ionization energy is the amount of energy required to take an electron away from the atom, creating a cation, or a mole of electrons from a mole of atoms. And as the Z-effective increases, the ionization increases, energy increases, because the nucleus is stronger, and so electrons are reluctant to leave. It takes much more energy to pull an electron away. Incidentally, this always has to be done in the gaseous state so that I have equal access to all of the atoms. One thing about the ionization energy is that the first ionization energy is always less than the second, is always less than the third. As I become more positively charged, it becomes harder and harder to remove other electrons. And if I start to get into that island of stability where I achieve a stable electron configuration, I will usually see a huge increase in the amount of ionization energy that it takes. This fourth one, electron affinity, is something that only honors students need to understand. So the electron affinity is the ability for an atom to take an electron away from another atom, or a mole of electrons from another mole of atoms, to become an anion. So as the Z-effective increases, the electron affinity increases because it has a stronger nucleus. It becomes a little challenging because ionization energy and electron affinity have the same trend, right? As my Z-effective increases, my ionization energy increases. As my Z-effective increases, my electron affinity increases. And it seems like it's backwards because this is becoming negatively charged, this is becoming positively charged. But you have to understand that the ionization energy is a measure of how hard the atom fights back at losing that electron, and this is how strong that atom is in pulling away an electron. And the final trend is really talking about something in which we are having a shared pair of electrons, and that's when we form bonds. So the electronegativity is the pull of the nucleus on a shared pair of electrons. So as the Z-effective increases, the electronegativity increases as well. So remember that as I go from francium to helium, my Z-effective increases. So as I go from francium to helium, my atomic radius will decrease. As I go from francium to helium, my ionization energy will increase. As I go from francium to helium, my electron affinity will increase. And as I go from francium to helium, my electronegativity will increase as well. So understanding Z-effective really enables us to understand all of the periodic trends. So rather than trying to memorize all the periodic trends, it just makes sense to memorize the Z-effective and the reasoning behind the electron configuration. So distance from the nucleus, shielding, and if those two are the same, the number of protons, and it becomes easier to understand these trends.